Welcome to Unit 8-4. This is actually our last lesson in Unit 8. Pretty straight and to the point here. Today we're going to be looking at linear inequalities. But first, let's take a look at our math career for today. Hey, look at that. It's a mathematician. All right, mathematicians. Mathematics is one of the oldest and most fundamental sciences. Mathematicians do research in fields such as logic, set theory, abstract algebra, number theory, geometry, topology, dynamical systems, combinatorics, game theory, probability, and statistics. Although math has numerous applications, mathematicians also find math interesting in its own right, of course. You can see mathematicians' degree in mathematics, you pretty much pick a field that you want to go into, whether it be medicine or any number of things, computer science, study, theory, teaching, etc. Of course, you're going to need lots of math, but it's all fun stuff. Anyway, if you want to pursue that, I can give you more information as well as needed. Alright, today we're going to learn to graph and solve linear inequalities in two variables. Okay, you're going to get this pretty easily here, but we are going to need to take some notes. A linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. You can see down here at the bottom, I've got just the same example here, but what's different? The equal sign is replaced with an inequality. This says y is equal to 2x plus 1. This says y is strictly less than 2x plus 1. So we'll find out what that means in a graphic sense in a second. Right there. Okay. Let's see. Also, we have a solution of a linear inequality is any ordered pair that makes the inequality true. So when you're looking at something like this, if you plug a 3 in here for x, and a 5 in for y, you're going to get 5 is less than 6 plus 1. Of course, that's a true statement. So this is a solution to our inequality. Alright, so your turn. Each of the following, tell if the ordered pair is a solution for that inequality presented. You can go ahead and give a thumbs up or a thumbs down here as we go forward. Okay. So what do you think? We've got y is less than 2x plus 1, and they give us 3, 5. Well, this looks familiar, doesn't it? So what do you think? Thumbs up for yes, it's a solution. Thumbs down for no. And yes, that is indeed a solution. Good. How about this one? Y is greater than or equal to x minus 4. So what are we going to do here? We're going to plug a 2 in here. 2 is greater than or equal to 7 minus 4. 7 minus 4 is 3, correct? So that should be a thumbs down on that one. How about this one here? Y is strictly greater than x minus 7. Well, y is 1 and x is 1. 1 is strictly greater than 1, subtract 7. 1 minus 7 is negative 6. A positive number is always larger than a negative number, so thumbs up on that one, yes. Okay, how about this one? Y is less than or equal to 2x minus 8. 2x minus 8. So let's see, negative 8 goes here, 3 goes here. I've got 2 times 3 is 6. 6 subtract 2. 6 subtract 8 is negative 2. Thumbs up. Good. Negative 8 is less than or equal to negative 2. Alright, so consider this equation. If x equals 3, how many possible solutions are there for y? So y equals 2x plus 1. Let's plug a 3 in there and see what we get. If we plug a 3 in, we end up with 7 as the only solution. It is an equation. It's saying that 7 is equal to 6 plus 1. True statement, of course. Now compare that to an inequality. If x equals 3, how many possible solutions are there for y? So if we plug in a 3, we're going to say y is less than 2x plus 1. So if we start looking here, you're going to start seeing all these things in the purple boxes are possible solutions. Instead of there being one solution only like an inequality, if you take a look here, you're going to see that we can just keep writing ordered pairs and writing ordered pairs, and we can keep filling them up. And we could go on, of course, forever and never stop. This is the power of inequality, is it gives us way beyond one solution. It gives us infinitely many solutions. All right. Now, of course, it's going to be very impractical to list all these solutions. So when we're dealing with graphs, it's much easier than that. Take a look at the following graph. You'll notice you've got green at the top left and pink at the bottom right. We've got blue dashed line, a red solid line, the white in the middle. Let's take a look at this. Notice this piece right here. Y is greater than or equal to x plus 2 is this piece, and y is strictly less than x minus 2 down here at the bottom piece. So let's look at some distinguishing characteristics here. It says the lines that were solutions for linear equations are called boundary lines. So these lines that we graph, the red one here and the blue one here, these are called boundary lines of our inequality. Those two right there. Okay. Let's see. When an inequality is written with either y is greater than or equal to or y is less than or equal to, the boundary line is solid. You'll notice here that we have this red one. So focus right here where we've got greater than or equal to, less than or equal to. So if you have that equal to sign underneath, you get a nice solid line in your graph. Now, if it's dashed, we're going to get a strict less than or equal to, which simply means that all of your answers are below or above the line. That does not include the line as an answer. So this means everything below the dashed line but not including it. So strictly greater than, strictly less than, as opposed to the one that had the equal sign, it includes the line in the answer. Alright, when an inequality is written with either greater than or equal to, we shade above the line. All of these up here, possible ordered pairs, are solutions to an inequality. And of course it's not limited by this box, it goes on forever and ever way up here. But it's everything above and including the red line. If it's something that's below, it'll say less than or less than or equal to. It's below the line that the boundary line that you've graphed on your paper there. Okay, so this happens to be this inequality, and this one is y is strictly less than x minus 2. Notice we've got the greater than or equal to, we have a solid line, and we shade above with a y-intercept of 2. This is less than, so we shade below, and it's got a dashed line there. Alright, so in your notebook, let's graph the following inequality. I'll do my best here to help you along. We've got y is greater than or equal to negative 2x plus 4, so let's work together here on this one. And let's see, I'm going to have to do all this freehand here. So, let's ask the following question. Is y isolated? Well, in this inequality, indeed y is alone, so we're all good there. We don't have to try to isolate y or set it by itself. It's already done for us. What's the y-intercept? So if I look here, the y-intercept is going to be positive 4, so it's going to be sitting right here, positive 4. What's the slope? Well, the slope's negative 2. So negative 2 simply means, remember, it's rise over run, so it's going to be negative 2 over 1. So I'm going to go down 2 over 1, down 1, 2 over 1. Okay? Now, before I draw this line, I need to determine, is it going to be a solid line or dashed line? So we look right here. That, to me, looks like a solid line because it has the less than or equal to in it. So I'm going to have a solid line that goes down like this. I don't have the benefit of a ruler or a straight edge here. And now the last thing is, are we shading above or below? Well, this is y is greater than or equal to, so we're going to shade above the graph where the y values would increase. So it would look something like this. Alright, so each time you just have this checklist to go through. Follow the checklist, you're going to be right all the time. Okay? Alright, let's try another. Let's try this one. So, y is strictly less than x minus 3. So let's take a look. Let me grab my trusty pen here. And let's start at the top. First of all, is y isolated? And of course the answer here is yes, y is alone. What's the y-intercept? Well, the y-intercept is this b value out here, negative 3. So put a dot here, negative 3. What's the slope? Looks to me like the slope is, this is the coefficient of x is 1, so it's going to be up 1 over 1. Up 1 over 1. Remember that the slope is this number right here, 1. And it's rise over run, 1 over 1. And now, solid line or dashed? Solid line or dashed? Looks to me like I've got a strictly less than, so it's going to be a dashed line. So instead of having a solid line, I'm just going to break it up like this. Okay, there we go. And finally, do we shade above or below? Well, y is less than this function, so less than, It's where the y values are decreasing, so we simply shade below the graph. That's it. Nothing to it. All right, I think I have one more. This one I'm going to kind of let go of the handlebars here and let you ride off on your own, and then I'll catch up to you. Okay? So go ahead and have at this. Go ahead and press pause on the video here. See what you can do with this graph, and we'll be right back together in just a second. Alright, here we go. I'm going to start at the top. Is y isolated? Sure is. Y is isolated. That's good news. Then I'm going to ask, what's the y-intercept? Well, the y-intercept is -1, so I'm going to put a dot at -1. That gives me a place to look. What's the slope? The slope in this case is 2, or 2 over 1, so up 2 over 1, up 2 over 1. Is the line solid? Is it a solid or dashed line? This is a strict inequality. I don't have any line underneath it, so it's going to be a dashed line. And hopefully you got a dashed line there. And then finally, do we shade above or below? Well, because it's greater than, I'm now going to shade where the y values increase as the function moves forward. So we end up with a shading that's above this dashed line. The dashed line simply means that any ordered pair on the dashed line is not a solution, but everything above it certainly is. Solid line would include all the points on the boundary line. Alright, so let's see how we did. I think we have finished Unit 8. We certainly have. There's more instruction there at the top. Just navigate to the site, punch in that search code there, and watch video example 1 and 2. You have some digital scored practice there at the bottom if you'd like. And we'll talk to you soon.